Hey everyone, so in this video I'm going to go over simplifying radicals, which is sort of an Algebra 1 review. So hopefully this is not too crazy for you guys. The first thing I'm going to go over though is the do now. It says explain one way you can determine if a particular x value is a root of a given polynomial function. We talked about this sort of in the last lesson, and if it was a root, it would cross the x-axis. You could also see if the y value equals 0 at that x value, which means that it crosses the x-axis. And you could also do division with it if you knew the value of x and put it back with the forms, like if say x was equal to 2, if you divided that polynomial by x minus 2, you would be able to find out if the remainder was 0 and then see if it was a root of the function. Okay, so let's talk about radicals. A radical sign is used to indicate the square root of a number, of one of two equal factors of a number. Okay, so square root of 9 is 3, because 3 times 3 and negative 3 times negative 3 is 9. So technically it's plus or minus because of this fact. But whenever you see just the square root of 9, we refer to that as the principal square root, and you really should only give the answer 3. Because the principal square root is the positive answer. We do know, though, that negative 3 times negative 3 is also 9, so it is an option. When seeking the root of another square, anything other than a square root, so if you have like a cubed root, a fourth root, you want to look out for this. When you don't have those numbers there, it's automatically assumed that that number is 2, and you're taking a square root. But this number here is called the index, and the index tells you the type of root you're taking. So you're either trying to find out, like for example, the cube root, what number times itself 3 times gets you that number inside. With a fourth root, what times itself 4 times gets you that number inside. So the index is very important. It tells you what type of root you're taking and how to properly solve for it. And just so everyone knows, if we remember, inside of here, like when I write my root symbol, this is the index, whatever the number is, and then the inside is called your radicand, whatever number or whatever's inside of there, and this symbol right here is just the radical symbol. So it's very important that when you talk about a square root, you're saying square root and not radical. I make that mistake all the time because you want to specify what type of radical you're referring to. Okay. So like I said, the root here is very important, okay? You can get the cube root if you press the button math. You will see it. So press math. I'm doing it right now on my calculator. If you press math, you will see it as choice 4. And you will have like the 3 and like a parenthesis. Just type in 8, and you guys should see that the cube root of 8 is 2, and this makes sense because 8 breaks up into 4 and 2 and 2 and 2. 2 times 2 times 2 is 8, and they're all the same, hence it's a cube root, perfect cube. Try that with the fourth root. Now you might not see the fourth root, but if you press math, so everyone press math on your calculator, I want you to find choice 5. It's the choice with the X in it, if you see it. When you press that, it will let you change it to a 5 inside of your calculator, put 81 in, and then you'll end up getting your answer, and you'll find out that 3 is the root of this. So 81 is a perfect fourth, because 3 times 3 times 3 times 3 is 81, which does make sense because 3 times 3 times 3 times 3, that's 9, 9 times 9 is 81. Any radical without an index is understood to be the square root. The radicand is the inside of the radical, so the radicand's in there. Okay, but again, any radical without a number here is understood to be a square root. So when the radicand is a perfect square, we remove the radical sign and we can make a value. So your square roots are, the square root of 4 is 2, square root of 9 is 3, 16 is 4, 25 is 5, 6, square root of 49 is 7, 64 is 8, 81 is 9, 100 is 10, 121 is 11, 144 is 12, and so on and so forth. But when the radicand is not a perfect square, when the number inside, we need to know how to simplify it. And basically what we're going to do is break it down. We're going to factor it down, find the largest perfect square that goes inside of that number, and write it as a product, and then simplify. Okay, so we're going to do a few simplifying here. If you remember back in, I don't remember what grade you guys were in. I think it might have been 7th grade or 6th grade. You guys learned about factor trees. And what you would do is you would like split it up into 9 and 3. So what we're going to do is split it up though with square roots. In this case, we're dealing with a square root because there was no number inside the index. So I break this up and then I ask myself, can I take the square root of either of these numbers? And you can. It would be 3. And then this guy stays in the house. So I think of it this way. 27 is not a perfect square. But I'm going to try to break it up where there's something perfect as a factor. And then I ask myself, which factor is perfect? 9. 9 is perfect, so they get to move outside of the house. The 3 has to stay inside of the house because it's not perfect yet. So I think of it as like when you're perfect, you get to move out of your home. But your siblings might not be perfect yet. They're not ready for the adult world. So they stay inside the house with you, without you, and you move out. Okay, so that's how I think of it as. Okay. So you might need help getting the factors of these numbers. So remember the factor trick. To get your factors, you would go to y equals and you would do 80 divided by x. And then you'd look at the table and you can look at the rows, like the x row and the y row, and you can find out the factors that are inside of 80 where one of them is perfect. So when you look down it, you should see that 16 and 5 are options there. And we're going to pick those because 16 is a perfect square. So let me just rewrite this. That kind of got sloppy. So really your goal is to find the highest perfect square inside of 80. I do know that 4 divides into 80 and 4 is a perfect square, but 16 is the highest perfect square, and you want to take out the highest because it'll allow you to simplify quicker and it'll be easier that way. So 1/2 is just going to chill. It's connected by multiplication, so whatever I get out of here, I'm going to multiply by it. The square root of 16. 16 is the perfect number. I will take out 4 and square root of 5. Now, I need to make sure that you guys don't keep the radical. Once you square root the thing, the square root disappears. Don't write another square root over this. It happens all the time, especially when you have the square root of 16. Because it becomes 4, people want to break it down to 2. But it's done. This is the square root of 16, and it became 4. Now, the only reason why this one in particular is going to become 2 is because we're doing 1/2 times 4, because that's the added step, and you get 2 square root of 5. Okay. This is your first example with exponents, with letters. So to make your life easier, sometimes what I do is I just break it up. You can separate the radical like this. It's allowed. And we'll just deal with the numbers and the letters separately. So again, I would go to y equals, and I would do 72 divided by x, and I'd look at my table, and I want to see my biggest perfect square. And when you look down the row, you should see that the square root of 36 times the square root of 2 gets you 72. 36 will break up into 6, and you get square root of 2. Now you're left with x squared and y squared. Remember that the index here, all right, I'm going to try to make this bigger so you guys can see what I'm talking about. The index here is 2, okay? So the easy trick here is that if you can divide 2, like the power by the index, power by the root, this is called power over root. We're going to go over this a little bit further later on. You can get the simplified version. So I'm going to do 2 divided by 2, and I'll get x. 2 divided by 2 again, because there's a 2 there, you get y. Okay? So then what you're going to do is you're going to take anything that's outside of the radical, the 6, the x, and the y, and pull it together in the front. And then this, whatever is left inside the house stays inside the house. Okay, same process. Break this up. I like breaking it up. It makes it easier for me, but you don't have to if you don't want to. 18 breaks up into 9 and 2. Which one's perfect? The 9. Square root of 9 is 3, and you'll keep 2. Square root of x squared, well, the root here is 2. 2 divided by 2 is 1, so we get an x. And this guy does not simplify because it's 1 and 2, and 1 over 2 is a half. It doesn't divide evenly, so unfortunately the y does not come out of the house. Whatever is outside the house, the 3 and the x is going to pull out in front, and then whatever is left inside, any radicals, they kind of come together and join the party as one whole piece. So these guys are going to join together because they're still inside the radical. Square root in this case. See, I do it all the time. Okay, break this up. -8, we're going to do the cube root. This is our first example where we have a cubed root, so please be mindful of this. Always check, obviously, if -8 is a perfect cube, and it is. When you take the cube root of -8, you get -2. Divide your power by your root. 3 divided by 3, that's 1, so I just get y. And that's it. Next question. Split this up. This is a 4th root question, so be very mindful of it. Take the 4th root of 16, and the 4th root of 16 is a root. It's 2. Again, if you don't remember what that is, you press math. You're going to choose choice 5, and then you put a 4th in that little x area. And then to simplify this, power divided by root. So 8 divided by 4, that's x squared. Okay, and this should make sense because x squared times x squared times x squared times x squared, that adds up to 8. 2 plus 2 plus 2 plus 2 is 8. So that's why it's becoming just an x squared. Okay, moving right along. Being mindful here, we have a cubed root, so I'm going to split this up into the cube root of 27, the cube root of x to the 6th, and the cube root of y to the 3rd. And I'm going to see if I can take the cube root of 27, and you can. Go to math, choose the cube root. On your calculator, cube root of 27 is 3. Can you divide the power by the root here? Yes, you can. 6 divided by 3 is x squared. Can you divide the power by the root here? Yes, you can. It's y. Okay? All right. Take the 5th root of 32. Again, to get the 5th root, you're going to go to math. You're going to choose choice 5, and you're going to pick the one with the little x in it, and you're going to change that x to a 5 in your calculator, and that gets you 2. And you're going to multiply that by 1/2, and 1/2 times 2 is 1. Okay. Next one. There is a 2 here. You just don't see it. It's a square root. Power over root. That gets you x to the 5th because 10 divided by 2 is 5. Next one. This is our first example where we're running into a little bit of an issue. You're dividing by 2, and unfortunately 11 divided by 2 does not happen. Okay? There is a few ways to do this, and I'm going to do it 2 ways. Mrs. Kistner has a way, and I have a way. Mrs. Kistner is my co-teacher if you're not in first period with me. But here's the deal. There's 11 x's in there. Okay? So what I do is I think of the first number below 11 that can divide by 2, and that would be 10. So I can break this up into x to the 10th and x to the 1st. This still adds to 11 because you're following properties of exponents where they add to 11 when you multiply. And then you would end up getting x to the 5th, and this guy would hang out inside. Now what Mrs. Kistner does instead, and this works for some people, and I do it sometimes too because it's easier and in some instances, is what she does is she does the whole power over root thing, like what we were trying to do before. And you would do 2 divided by 11. And you would ask yourself, okay, 2 goes into 11 5 times, and then you do division. 5 times 2 is 10. Subtract how many do you have left over? 1. So 5 x's come out, and whatever remains stays inside the root. Okay, so this is how many come out. This is how many stay inside. Okay? So that's what we're going to do for the other examples here. If you want, you can pause the video and try to do J. So pause it and then try it. So if you're going to do it my way, find the first number that would be divisible by 2 because this is a square root and it would be 8. The square root of x to the 8th is x to the 4th, and you'd get x. If you do it Mrs. Kistner's way, do this. 2 goes into 9 4 times with a remainder of 1, and 4 x's come out, and 1 x stays inside. So either way, you get the same answer. It doesn't matter. Next one. Split this up. Makes your life easier. Square root of 36, boom, 6. That was nice, because that is a perfect square. You can do it my way. Think of the first perfect square, or the first number divisible by an index of 2 below x cubed, and it would be 2, and then this comes out as x, and this is going to stay inside because it's not perfect, and the 6 drops down. Okay? But again, you could do 3 divided by 2. This goes into it once with 1 remainder left over, and that's why there's 1 outside and 1 inside. Square root of x to the 7th, square root of y to the 12th. This one, remember there's an index of 2 here. 12 divided by 2 is y to the 6th. That one was nice. That one breaks down nicely. But this guy does not divide by 2. So 7 divided by 2 goes into 7 3 times. 2 times 3 is 6 with 1 left over. So this means that 3 x's come out and 1 x stays inside. And then whatever's on the outside of a radical, they come together in the front. And then whatever's left over falls back behind. Okay. Last question. It says, if 5x squared and the cube root of 2 equals the cube root of a, then which of the following is equal to a? So basically, if you notice, there's nothing in front here and there's only a on the inside. So this means that this somehow was inside of that. So we're going to kind of think backwards here. We're also going to remember this is a cubed root. So to get back in there, you'd have to do 5 cubed and x squared. Well, let's make this easier on ourselves. The opposite of a cube root is cubing something. So I'm just going to cube the whole entire thing. And when you cube the whole entire thing, you would get 5 cubed, which is 125, and then x squared to the 3rd, that's x to the 6th. That's what would go in here. But there's also a 2, so you're going to do 2 times that, and that would get you 250 x to the 6th. And that is your answer, because this would be what would be on the inside, and that is what would be a. So I hope this video helped you with simplifying radicals. There's another video that I have as well if this one didn't help you, but hopefully it did.